In this video, we introduce the concept of applying control to DC-DC converters. While there are various types of control approaches, we will mainly focus on feedback control. To fully grasp the concepts covered here, you should have some background in DC-DC converter operation and control systems. Control systems have three basic components: the plant or system, the control objective, and the controller. Let's look at each of these more closely. The plant is a system that you are trying to control. In control systems, a plant has a number of states that are affected by one or more inputs in the system. Based on these states and inputs, there are one or more outputs. Let's take a closer look at the DC-DC converter as an example. In common DC-DC converters, like the buck-boost and the buck-boost converter, the states are usually the inductor current and the output capacitor voltage. For the inputs, the switch duty ratio is the main input, but the input voltage can also be defined as a system input. For the outputs, we say that the converter output voltage and current, as well as the input current, are outputs. Keep in mind, the input and output power for the converter are not the same as the plant system input and output. Think of the inputs to the system, the plant, as things that you can measure in your system. Also, there are many ways to define and model the same system, so your system can change depending on what you are trying to achieve. In general, systems can be quite complex or relatively simple. For feedback control, we want to simplify complex systems into simpler systems so that we can more easily work with them. For feedback control, it is easiest to work with a single input, single output, or SISO system. To simplify complex nonlinear systems like DC-DC converters, we first have to pick our controllable input and our target output. Then linearize the system. After simplification and linearization, the states stay the same, but our SISO model for our DC-DC converter will have the duty ratio as the input and typically output voltage as the output. The next control system component is our control objective. This is the target of your control. What are you trying to achieve in your system? The target for many DC-DC converter systems is a constant output voltage, but it could also be a constant output current or inductor current. When we linearize a system, we should already know which of the potential outputs we want to control. For the example system shown here, we have chosen output voltage, which becomes our SISO system output. The next step is to determine the target value for this output. This is the actual control objective. Let's say that we are making a DC-DC converter that will power a 5-volt USB device, like a mobile phone. We want the output voltage to be 5 volts, regardless of how much power the phone is using. In this situation, our control objective is to maintain the output voltage at 5 volts. The last control system component is the controller. In this video, we are looking specifically at feedback control, and the general diagram for feedback control is shown here. Here is our system modeled as an SISO system. The output that we are trying to control and our control objective for that output. For the feedback control, we take the difference between our control objective and the actual output to get the error. This error is fed into the controller, and the controller must determine the correct input to the system that will cause the system output to reach the control objective. The controller is the key component in achieving a well-controlled and high-performance system. A very standard controller is a proportional integral derivative, or PID, controller that is covered in standard control material. There are many different types of controllers, and we will introduce some basic controllers for DC-DC converters later on. To summarize, our three control system components are the plant, control objective, and controller. You can see them here in our diagram for a feedback control system. In our simple example of a DC-DC converter used to power a mobile phone, our plant input is the converter's switch duty ratio. Our plant states are the inductor current and output capacitor voltage. Our plant output is output voltage of the converter. The control objective is to maintain the output voltage at 5 volts. And our controller may be a standard PID controller that drives the converter duty ratio. This is the basic approach for applying feedback control to DC-DC converters.